So we've been looking at multiple proportions, and we talked about the two types of statistics we could compute here, the MAD statistic or the chi-squared, and we simulated. And really, for theory-based, the theory-based approach in mathematics is to use the chi-squared. And actually, chi-squared refers to the theoretical distribution, and we were seeing that in the simulation. Now, to go with the theory-based, there is conditions, as always. And if you recall, when it came to proportions, we were always doing at least 10 successes and at least 10 failures. So what that means in a multiple proportion setup is the actual observed values here in all of our cells need to be at least 10. So 151, 25, 114, 12, 76, and 22, all of those are at least 10, so we're good. So we can use a theory-based approach. But that's our validity condition for theory, is all cells greater than or equal to 10. So that's basically saying at least 10 successes and 10 failures in every category. So just extending the idea we had for a single proportion or two proportions. So the theme continues on there. So let's go to the applet and see what we get with the theory-based approach. So we really go to the same place. Here's my data again, my abbreviations that I was using. And we pasted them in here, used the data. We got our nice segmented bar graph. And you have this option of choosing chi-squared or MAD. When we're doing the theory-based approach here, we really want chi-squared. And here was our distribution. We got a chi-squared of 7.398. And so we counted the likelihood of being that far out or farther in that distribution, in that chi-squared distribution. And I pointed out that you could even overlay. Well, when you overlay, there is your theory-based approach. This has nothing to do with the simulation. All the theory-based approach is doing is taking a theoretical chi-squared distribution, that blue curve, and computing the area out past 7.398 on that chi-squared distribution. So you would come to the same place that you would for simulation, the multiple proportions applet, but you would just click on this overlay chi-squared distribution and you get to see the theoretical curve, and there's the theoretical p-value. It's still pretty much in the neighborhood of our simulation, which it should be, right? Because when we simulate, that should be a legitimate computation. And the more shuffles we do, we should see this number get closer and closer to the theoretical value. So if we just kept doing thousands and thousands of more shuffles, we're going to see maybe this last digit change a little bit, but it should get closer to 8. So this is sort of the limit of what happens with infinitely many shuffles. And that's all you need for a theory-based approach, is just to click on this overlay the chi-squared distribution.